Hello students, today you will learn about prime factorization from chapter 4. First we will see the definition of prime factorization. Prime factorization is to write a number as a product of its prime factors. So basically, the prime factorization of a number involves breaking down that number down to its prime factors. For example, the prime factors of 126 will be 2, 3 and 7 because 2 multiplied by 3 multiplied by 3 multiplied by 7 is 126. There are two methods of finding prime factorization. So there are two main ways for finding the prime factors of a number. The first method is the factor tree method and the second method is continuous division method. Let us first discuss about factor tree method. A factor tree is a diagram that is used to break down a number into its factors until all the numbers left are prime. Now let us discuss the steps to be followed in factor tree method. So let us take the example of 24. Suppose we have to write the prime factorization of 24 using the factor tree method. So what we are going to do is, we will first consider 24 as the root of the tree. Then we will write a pair of factors as the branches of the tree. So basically, we split 24 in its factors. So here we splitted 24 as 2 multiplied by 12. Now here, since 2 is a prime factor, we will leave 2 as it is. And we will further factorize the composite factor 12 as 2 multiplied by 6. Now again, since 2 is a prime factor, we will leave as it is. And we will only factorize the composite factor 6 as 2 multiplied by 3. Now, the factors of 6 are 2 and 3 and both are prime. So we can stop the process here because we got the prime factors of all the composite factors. So the prime factorization of 24 is 2 multiplied by 2 multiplied by 2 multiplied by 3. Now let's discuss about the second method, that is continuous division method. In this method, we divide a given number by its prime factors. The division process ends when the quotient is a prime number. Now, let us look at the steps to be followed in continuous division method. First, we divide the number by the smallest prime factor, which will divide the number exactly. In the second step, we divide the quotient again by the smallest or the next smallest prime factor. We repeat the process again and again till the quotient is a prime number. And the point to remember is, we use only prime factors to divide in this method. Now suppose we have to write the prime factorization of the same number, that is 24, using the continuous division method. So this time we will do the factorization of 24 using continuous division method. And we know that in this method, the first step is to find the smallest prime factor of 24, which can divide 24 exactly without leaving any remainder. Since 24 is an even number, we can divide it by the smallest prime factor, that is 2. So we divide 24 by 2, and when we divide 24 by 2, we get 12 as the quotient. And we know that 12 is also an even number, so we can divide it by the smallest prime factor, that is 2. When we divide 12 by 2, we get 6 as the quotient. Now, the quotient 6 is also a composite number, so we also need to divide 6. So we need to find a smallest prime factor which can divide 6 exactly. Since 6 is also an even number, so we can divide it by its smallest prime factor, 2. When we divide 6 by 2, we get 3 as the quotient. Now since the quotient is a prime number, we can stop the division. So the prime factorization of 24 is 2 multiplied by 2 multiplied by 2 multiplied by 3. Now let's solve one question from exercise 2. Question number 1. Write the prime factorization of the given number using the factor tree method. Use the continuous division method to check your answer. Number B, 210. So here, first we will find the prime factorization of 210 using the factor tree method, and then we will check our answer using continuous division method. So let's first find the prime factorization of 210 using the factor tree method. So in the first step, we consider 210 as the root of the tree. Then we write a pair of its factors as the branches of the tree. So basically, we split 210 as 2 multiplied by 105. Since 2 is a prime factor, we leave 2 as it is. And we further factorize the composite factor, that is 105, as 3 multiplied by 35. Now since this 3 is also a prime factor, we will leave it as it is. And then we will factorize the composite factor, that is 35, as 5 multiplied by 7. Now, since we got the prime factors of all the composite factors, we will stop this process. So the prime factorization of 210 is 2 multiplied by 3 multiplied by 5 multiplied by 7. Now, to check our answer, we will use the continuous division method. In this method, we will first divide 210 by its smallest prime factor. Since the last digit of 210 is 0, it can be divided by the smallest prime number, that is 2. So when we divide 210 by 2, we get 105 as the quotient. Now since the quotient 105 is a composite number, so we have to continue the division. So we have to divide 105 by its smallest prime factor. Since the last digit of 105 is 5, we cannot divide it by 2. So let's divide 105 by the next smallest prime number, that is 3. So when we divide 105 by 3, we get 35 as the quotient. Now we can see that the quotient 35 is also a composite number. So we need to continue the division. We have to divide 35 by its smallest prime factor. The smallest prime factor of 35 is 5. So we will divide 35 by 5. And when we divide 35 by 5, we get 7 as the quotient. Now since the quotient is a prime number, we can stop the division. So the prime factorization of 210 is 2 multiplied by 3 multiplied by 5 multiplied by 7. And it is same as the prime factorization that we got by using the factor tree method. So our answer is correct. So students, that's all for today. Thank you.